So we're back here to the PowerPoint. So what I've done is I've actually gone through and I've just given you some examples in terms of methodology, how we would look. So for instance, in this case, we have 8 jars. And what was done here first was to determine the optimal pH. So what you see is we've got a control here. In this case, an alum dose of 45 milligrams per liter was used, and the pH was varied from 4 to 8. So that same process that I just showed you that was done in the environmental labs, and we would have, had we been in person, we would have done that as a demo, but that's not to be. So what one would do would be measure the turbidity. So this is the turbidity of the control, so with no treatment, but having gone through the entire process. And then you can see here the turbidity of the samples. We may also, in some cases, do UV 254, which essentially gives us an indication of the amount of aromatic hydrocarbons that are present in the water, and it's related to the naturally occurring organic matter. And what we see here is we have varying turbidity. We can plot that here, and you can see what we have is a typical curve that looks like this with a minimum value. So what we know here, okay, this is the residual turbidity. Sometimes this is the residual turbidity. And so what we see is that within a pH from about 5 to 6, we have the optimal removal of turbidity. And that actually corresponds to the solubility of aluminum hydroxide. So this is a PC-pH diagram or solubility diagram for aluminum hydroxide. This is the soluble species here. It doesn't like when I do cross-hatching. So this is the soluble species, and these are our soluble. So this is the insoluble species. And these are the soluble species. I think I said that backwards. Okay, so this is the precipitate, and you can see that a minimum occurs right around 5 to 6. Okay. And not surprisingly, when this data that I presented the other day, what you can see for alum is that a minimum occurs around 5.5. Basically, this is the optimal dose. So typically, and that corresponds fairly well with this range right here. For chloride, C actually has a higher range, a little bit lower and a little bit higher range. And if you look here, this is the solubility diagram for ferric hydroxide, and you see that it's shifted to the basic pH range. So it's not surprising that it actually is effective at a higher pH range, and that's one of the reasons why it's used over alum. So once we've determined an optimum pH, then what we want to do is determine the alum dose. And you can see here, pH is all constant at 5.5. The alum dose was altered from 10 to 100 milligrams per liter. Again, we measure their turbidity. So we go through the whole jar test. We measure the turbidity, and then we can plot that, and we can determine the optimal dose. So the optimal dose for this system is about 45 milligrams per liter. We may, in some cases, actually do a wider range and then do a second test where we try and narrow in on that optimal dose. So that's essentially the jar test.